Hello guys, Roofgoer here, and today I'm going to teach you or show you just a little programming technique I've made called the invariant representation, which as you can see I've implemented here in C++. But first, a bit of backstory about this invariant representation. So I was doing a bit of research on artificial intelligence recently, and I sort of found out that the problem was that people didn't actually know how the brain worked and tried to implement the way the brain functions in AI. Instead, they just tried to do it from a programming point of view, and so therefore it wasn't actually true AI. It didn't really work out properly. So yes, thinking about that, I decided to do a bit of research into how AI works in nature. And what I found out was that rather than remembering raw data like a computer does, such as the sequence 011101 blah 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 blah, it remembers an invariant representation, which is like a general idea for an object. When you see, hear, or feel any input coming in, you don't remember that raw input like a computer does. You remember it as a general version of something. So for a vision, you might remember every car is simply car. But anyway, yes, so this categorizing thing is what I believe allows the brain to have a lot more flexibility than computer programs. And so I've just implemented that sort of thinking here in a C++ program, which I will now just demonstrate to you really quickly. So first of all, let's look at the header file. Here I've declared a struct invariant rep. Since this was just a short, quick program, haven't really made this a class of its own methods, and I just, struct, okay, it's got string invariant formula, which is the equivalent of what the brain remembers. So this is the thing that the program remembers. And then it's got a pointer to a name. Sorry, I forgot to tell you what the goal of this program was, and that was it's meant to memorize equations. It's meant to memorize sequences of numerical operators. And the cool thing about this is, because it uses my invariant representations technique, it's very flexible with them. But anyway, okay, so here we've got the string invariant formula, which is meant to memorize that sequence, and the string, and the pointer to a string pname, which is meant to memorize the name of that sequence. We've also got a terms thing here, which is meant to memorize how many terms there are in that specific equation. So now that we've got that really important data type down, let's look at the main thing. So here I've declared a string input, which is really just as like a temporary thing for the to get some input from the user. I've also got integer current, which is the current node on the array. So I've declared two arrays here, one to hold all the names of the equations it remembers, another one to hold all the invariant representations of the equations. And this integer current over here just remembers what is the current node that we're looking at. I've also got msize, which is short for memory size, and yeah, as you can see, all the arrays have been declared to memory size. Okay, so just got this massive while loop here, which should really just keep going through the program, unless of course input is equal to exit. Simple get out thing, if you enter exit here, or exit loop in the program. But anyway, continuing. Here I've declared a variable of our new struct invariant rep. Okay, so here I've asked the user to enter an equation. and that equation has been entered into input, and now this invariant representation, its formula will be set to input. But this input, because if you ask human to input an equation, they'll put in something like 5 plus 5. But we want to remember the invariant representation. We want to remember the category for it. So here we have a function which I've called that's called CreateInvRep representation down here. So what that does is it takes a variable, yes, so we've got that, and it goes through every letter in its invariant formula and turns every number here into an underscore. So rather than remembering 5 plus 5, remember underscore plus underscore, which is effectively invariant representation it, because it no longer is susceptible to, fluffing up because some numbers are different. It just compares the sequence. It doesn't compare the numbers at all. It just compares the sequence because all the numbers are gone. They've been replaced by an underscore. So yes. And here I've got another thing called compress, another function called compress, which if we go down here we go. And what it pretty much does is, you know how sometimes people might input double numbers like 56. We don't want to remember 2 digits, we just want to remember a number. So what it does is just compresses an underscore and an underscore, because it was a double digit number, into just one underscore. That should give you the sequence, the invariant sequence here. And here I've just made a pointer to an invariant representation, which should be assigned to this retrieve function. What that does is it just goes through our memory, and if the invariant representation question is, like found in the memory, aka the program has seen this before, it's remembered it, it will return a pointer which points to this invariant representation in memory. Otherwise, it will return a pointer which points to null, aka it has not learned this before, this is something the program hasn't seen, it's new. So here we have an if statement. If this pointer is null, then here we go into this section of code, which pretty much what it does is get the program to remember another thing. Okay, first of all, this if statement here. If current, remember the integer from before, which represents the current node in our array. If current is equal to the size of the array minus 1, then we have to grow the array, because there's not going to be enough space left, it's going to crash, so we have to make it bigger. I won't deal with that because that's just normal programming stuff. Anyway, next one, it outputs the fact that it doesn't recognize whatever you inputted. So then it asks for the name of it, and it inputs that into the string names, the array of string names over here, so it can remember. So now it's stored the name of it. And now if you remember our invariant representation x, it declares the pointer to the name of x to the name which the user just inputted. So now it's got the name of the equation. It asked for the name of the equation, it's got the name of the equation. And here we have the biggest line of code in this program. It assigns this random variable which we declared to be put in memory. So now it has officially remembered it. It's got the invariant formula down and the name of it. And this here is just for the user's peace of mind to know that the program has remembered it. Now what happens if px was actually in the memory? Well, that's simple. It's already known it. All we need to do is have a few couts and output what it knows. So it will output that it already knows this one, it will output the name of it, and then it will output what it remembered, which is actually not the answer or the actual equation at all, but the underscored version of it. If you remember, that's underscore plus underscore for 5 plus 5 or whatever. Anyway, so I hope, so yes. one of the big things, okay, I think I've gone into quite a bit too much detail here. What's really important about this is actually this line right here, the function retrieve. Because what the retrieve does is it compares the invariant formulas of the memory to, to the invariant formula in question. But since these are invariant formulas, even if the numbers are different, then they'll still be declared the same. I think this will be better explained if I actually run the program. Teach an equation. It won't remember anything, so I'll just teach addition here. It doesn't memorize it. Addition. Okay, so now it would have remembered this equation here as an invariant form. Underscore plus underscore. It would have remembered its name as addition. So now if I type in any other addition problem, it will remember it. It will remember the name. It will remember what pattern it followed, because this has all been changed to underscore and this has all been changed to underscore. It remembers the pattern underscore plus underscore. So in simple words, this program remembers a simplified version, a categorized version of the input, and that's how it does its magic, really. Another example was multiplication. It should be remembering underscore times underscore. Doesn't know, of course, so I have to teach it. Oops, spelling error. And now if I do anything else, which is number, underscore number, number, asterisk number, it will memorize it as multiplication. So yes, I've just typed in exit twice, get it done with. So I hope you've got the gist of it here. What this does is I pretty much just stolen from nature. Like every other great invention in mankind, I've just done some research about nature, had a look at it, and I saw that the brain didn't work with raw data, but it actually worked with simplified versions of data. And here I've just implemented it in a little program which takes an input and recalls that input, and as you can see, it has flexibility with what numbers it uses because it doesn't memorize the raw data, it memorizes the invariant representation. Thank you. I'll probably be putting the whole source code in the comments, in the description, but if I can't, then hopefully just watch this over and over again until you get it. I hope I've explained it properly. I've only got 15 minutes, so I speak pretty fast, but thank you for listening to me. Thank you.